So my name is Oren. I work for ypyellowpages.com, and I live in an interesting environment. Most of our guys it's a mix of Ruby and Java guys, I would assume, right? And I find myself as the only true Node guy among those different technologies, and I'm trying to kind of like try to lead the change or to find spots where node.js is a good fit for us. And that's kind of my journey in the last few months, and I just want to share it with you. There's a guy, I think he's, excuse me, how many minutes do I have? 30? So I have no sense of time. That's how I roll. So you guys just stop me when I'm hitting 30 minutes. No, I don't care. I think the guy's name is John Medina. He's a brain scientist, and he says that there's mainly two ways to get people's attention and make them remember stuff. One is to scare them, and the other one is to talk about sex. I can't do any of those. So what I try to do is I created this, I'm basing my slides on a format called Ignite. Have anybody heard about Ignite? Few hands. So the idea of Ignite is to have 5 minutes presentation, it's 20 slides, and they're running by itself. I can't stop them. There's no time for questions, which is awesome because I can't answer anything anyway. And 15 seconds for each slide. So this format is the one that I'm going to use. I just took impress.js, which is another presentation format, the JavaScript and CSS3 transforms that makes nice animations. I cloned it and I just added the little timer here with JavaScript, so it will run automatically, and I have 20 slides, 15 seconds each. So it's going to be fun, or maybe humiliating for me, and fun experience for you. Those of you who have OCD might stare here at the numbers and will have no idea what I just talked about. Which would be great, because I'll have to repeat. Some of the slides have some code, but you guys are not scared of code, but it's kind of hard to digest in 15 seconds. So don't worry, don't get scared, and don't ask questions, because I have no time. All right, so let's start and see how it goes. All right, so I hit space and yeah. So that sounds. Use this 10 seconds. Yeah, I need to maybe start from the first slide. All right. So node.js. I'm in love, and I just hope that you guys will fall in love as well after this 5 minutes talk. I'll explain why. So node.js is basically writing JavaScript on the server. That's basically what it is. And the idea is to create very, very fast, scalable network applications. It was created by a guy named Ryan Dahl. He was a PhD student in New York. 2006, he started working on this. And he didn't like the performance you get from Ruby server. He was trying to build a server, a very fast server. He didn't like the fact that Ruby, MRI, using threads, it's very hard to scale threads. You're going to consume a lot of memory, a lot of CPU. And he was trying to build it in different languages. Google came in 2006 with the V8, and he built the node on top of V8. He presented in Germany. In 2008, it was a standing ovation presentation, 45 minutes, Google project, it's awesome. And then joined a company from San Francisco, decided to work with him. Now we're in very, very stable version, almost 0.8 right now. So basically, that's what it is. The main point here is it's the evented non-blocking I/O, which I'll explain in a few more slides and later on. There's about 20,000 lines of JavaScript and 20,000 lines of C and C++. The secret sauce here is the libuv that sits next to the V8. It's a C++ library, cross-platform, work on Windows, and give you the event loop and give you some other things I'll talk later on. I/O is very, very expensive in terms of the time it takes. This one is like a CPU cache, it's like a phone call. You take the phone call and you can talk. This one is going across to Florida, trying to pick up the phone that's over there. It's really hard. It takes years compared to a phone call. And this is the way that you did right now with I/O. So the Ruby way, most of the time you do synchronous. You can fork process, you can use multiple threads, which is expensive, CPU and memory, and you can use event loop, which Node is using. That's what you know, that the pseudocode of like a regular query to a database. So you just do db.query and then you wait. and you wait. And then you get the result and you continue and you do whatever you want, make another call. And this is a pseudocode of event loop. Don't get scared, just think about it, I'll explain later. It's some sort of a while, infinite while, and in the middle we're doing something, we're calling for sockets, I'll explain it later, and then we're calling our callbacks. Next slide is the way that JavaScript is doing I/O. So everything in Node, you're passing the last argument, you will usually pass a function. This function will be added to the queue that the event loop is listening to, and that's how I/O should be done according to the Node guide. That's Nginx versus Apache. Nginx using event loop. Apache, the old version, used to create a thread every time there's a request. Therefore, the memory is super high for Apache, and Nginx is really flat, the same with requests per second. And that's just a benchmark. Hello world. It's about 50 meg for a get, and about 5,000 requests per second. It's very impressive. That's about it. JavaScript. I hated JavaScript a while ago. I came to Ruby a few years ago. I love the syntax. I love the aesthetics. There's interesting aspects of JavaScript, the language. One of them is the closures, which I'll explain what it is later. And other things that give JavaScript great power to use evented I/O. And that the design goal of Node is to be very, very nice for people who like Unix. The Unix philosophy, and also great appeal for JavaScript guys who are used to JavaScript in the client. They know how to do asynchronous programming. That's the very, very core aspect, the callbacks, that anything that is I/O should not be done directly, it should be done with callbacks, and it's including networking or calling your database or even file system. Streaming is another good aspect that I will talk about. It's the same as the Unix pipes. It's a great concept, and that's Node's way of telling you that something is going to come in chunks and not in one big file or big data, which is important. That's the idea that unlike Ruby or Java, the core is very small. Node guys understood that let the community build most functionality in the modules, let's create something small, TCP, HTTP, UDP, and file system, and that's it. Let's the rest created by the community, which is NPM is the package manager. It's literally steroids. That's how I can see it. Just do npm install, npm search or docs, open the README for your npm publish to publish your gem or your module. The idea here is, unlike Ruby or Java, you don't need to extend a lot of classes to create server or create stuff. The focus is on using. I'm just using HTTP, which gives me, I'm out of time. So, what do you think of the format? Did you like it?
It's a little rushed.
Yeah.
Sounds like you're running.
I was running, yeah. But you enjoyed it, right? Who's the OCD guy that was watching the numbers and had no idea what I just... Oh, I see a bunch of fingers. OCD. All right, cool. So let me just go back to, I think the crucial point that I want to make sure that we understand. I think it's the event loop code piece. So those who raised their hands, do you want to tell me? Huh? No, now we're done with Ignite, that's it. Now we're... So, you want me to, maybe let me tell you what's going on here? Let's go to the next slide, actually. So when you're making a code, so anything in Ruby right now, the problem is Rails 4 is coming with live streaming. Anybody heard about live streaming? Great. So live streaming is an interesting concept. The idea is to send back data to the client while in the middle of the request. Don't wait until the end of the request. Send some pieces of data, make it more real time. That's where we're going to. It's not that easy. And you need, first of all, cultural. The modules that you guys are using in Ruby, most of them are not evented. Most of them are blocked. When you call your database, your MySQL, you're blocking the request. In Node is a pretty recent idea, the whole concept is to never block. So it's very, very easy. You cannot find a lot of modules in Node that will block you. And Ruby is the other way around, right? You will find most of the stuff that will block you. Forgot what I was talking about. Yeah, event loops, Node, Ruby. So there's a community aspect. The culture of Node is built toward the evented approach. Another aspect is technical aspect. In Ruby, correct me if I'm wrong, you have a few a few servers that will dispatch your application that are evented. One of them is thin, Puma might be another one, right? And if you're not using those, it's going to be a hard time to use streaming. So it's cultural and technical aspects that are hard to do in most of the environment, and those make it very, very easy. So that's the idea of in JavaScript. You're making a database query, and you're offloading it to somebody else. You offload it to this libup library, and you're passing this function here. It's an anonymous function in JavaScript. It has no name, and you're saying, hey, do your stuff. Go get me the tweets from Twitters. When the JSON comes back, then call this function. In JavaScript, it's single-threaded. Okay, so everything is. I have one process, and I have one thread that the event loop is running on. And when I'm back here in my code, then I'm back into my thread. Okay? And let's see what happened to this function that we passed. I think it's one slide back. So think about this function. It's being added to some sort of a queue or an array, which is the FDS here, file descriptors. Okay, so when you're making, let's say, an HTTP call, it's using a socket. So all your event loop is doing a polling. He's polling for all the sockets that are used, and each process has a defined number of sockets that you can use. By default, maybe on Debian is 2,000 maybe sockets per process. You can expand it to way more than this. So you have an array of those sockets that's doing something, and your computer just every tick of the event loop asking, hey, is there anything for me? Did Twitter came back with a request, and I have all the tweets? If the answer is yes, it looks to see if the status is ready. And if the status is ready, it goes to the array, take the function that we passed, and execute the function, and you're back in your main thread. So that's kind of the secret, and it works on HTTP calls, it's using it, and it works on database calls, which are also using sockets most of the time, depending on the implementation of the library, but most of the time that's the case. The only difference is in file system, because when you want to grab a file from your hard drive, I don't think it's using the same exact model. I think it's using some thread. There's some thread pools for this. But regardless, it's way more efficient, and maybe in the future, the file system will be evented as well. But that's kind of the case. So that's anything that you want me to?
Serial communication.
Serial communication in a vented fashion? Well, can you elaborate? I'm not sure if I... Okay. Okay, so you can do the same talking to hardware in an evented approach. Okay. So yeah, I think we're done with the slide, and maybe I'll show you what I have for you guys in terms of code. There's a few options. Can you still hear me? Am I loud enough? Okay. You get out of the full screen mode. So everything that I'm going to talk to you today, everything is available on my GitHub. The slides themselves, it's just an HTML page, and all the code I'm going to show you. So you can see that, I don't know if you can see, but I have simple hello world to show you. Number 2 is CommonJS. CommonJS is the way to organize code. Are you guys familiar with CommonJS or with AMD? So there's a bunch of ways to organize code in JavaScript. The approach that the Node guys took is CommonJS. It's very, very nice. It lets you create small modules in a file and then require them. So whenever you see require in JavaScript, it's basically grabbing a function or an object from this file. So this is the module. HTTP, I have a few examples of how to do GET or POST requests. Streams is how to use the concept of streaming. So let's say right now in Ruby, you want to upload a huge file, maybe a video, maybe big images. What normally happens is you load it to memory, right? And then you save it to disk. In Node, you don't need to load to memory. In Node, thanks to the streaming approach, you load a very, very tiny little chunk. And slowly you can pipe it into another request, or maybe pipe it to a different process that do image magic, manipulate your file, pipe it to another request, and stream it back to the server. So nothing is being loaded in terms of memory. So the memory footprint is very, very small. And therefore, companies like LinkedIn recently changed their infrastructure the middle tier that all the mobile devices are connected to are using Node now. And they used to have 15 VMs, I think Java, and now they reduce it to like four computers that can load, I think, 4 times the amount that those 15 can hold. And it's available, you can look online on their talks. So there's many companies that are doing it, and I see a lot of opportunities, and I see that the domination of Rails, or maybe the domination of MVC, was great a few years ago when you had one database to connect it to, and then you have an active record to interface with this single database, maybe with a table per model. And I think that the domination of Node is when you have today's world, you have multiple queries that you make. You're making queries to Twitter, and you're making queries to Facebook, and it's more than one HTTP call, and some services calling you if it's a push notification from Apple, so you have some state that you need to maintain. It's not as easy as it used to be, and that's where I see Node is going to dominate, and it is. Maybe it will take some time, but I think a few years from now it will catch on. There's other aspects which I can talk, I'm not sure if I have time, control flow, how to deal with asynchronous. On the mailing list every few weeks there's like a question, I love Node, but I can't deal with the style, the code. So there's a way to deal with this. There's some libraries that were written or just best practices. Socket.io is the real-time aspect. So with very few lines of code, you can send messages to the server, and the server can send messages back to the client. And it's great, especially for mobile devices. Mobile devices, you want connection to be persistent, right? So it's called a keep alive, right? I think it's part of HTTP 1.1, I'm not sure, but you have this keep alive that you always connect it to the server, and the server spits data whenever he wants to. So it's great on all the phones. And there's more stuff there to show you, but let's start with Hello World. I'll show you the kind of the canonical example, and I'll stop using the microphone. So let's go here. Okay, so the first thing I'm going to do is require the HTTP library. So to build a web server in Node, you already have the HTTP library. You don't need to require Sinatra or Rails or anything, right? So all you do is var HTTP. I'm requiring, this is a built-in library called HTTP. Okay? HTTP create server. Okay? Actually, I think I have the code here. Instead of typing it myself, it's probably too tiny, huh? Let me just save time, and I'll show you the examples I have here for Hello World. Server 1. Okay. Oh. I have it open somewhere else. I'm going to close this guy. Okay. So I'm requiring the HTTP library, and I'm just calling a function that I got. And the function is create server. Every request that comes to my server will land it here in the anonymous function. Okay? And then I'm going to respond end hello world, and I'm listening to port 3000. Nothing fancy, right? I need to run it, and when you install Node, you get this Node command, server 1. Okay? I'm going to hit it on port 3001. Oops.
Lightning fast.
Yeah. Amazing. We have something else running on port 3001. Let's see what's going on here. Server 1. Now I'm 3002. Yeah, I need a dash slash n.
It says it's on the left.
Beautiful. Let's see this guy.
It's real-time programming.
Beautiful. server 2, port 3001. Let's curl it. Woohoo! It's not the first time I'm trying this stuff. It's ridiculous. Use source? I'm going to take out Safari here. I don't care about internet connection right now. Let's see if that's related. Wow. Okay, something with the networking here is messed up. Don't blame Node, please. Localhost, all right. Hey, we're geeks. It works on curl, right? 127? Nada. Okay. Anyway, we got our hello world. And let's go back to the previous one. So yes, all we did here is creating a basic server, right? And this is kind of the same idea that I did here. It's the same as the previous example. The only difference is I wanted to show exactly what's going on here in terms of the different objects. And the create server return an object which is an event emitter. Event emitter is a concept in Node that you have objects that can emit events. So one of the events is request. So every time there's a request, I'm doing whatever I want to do, which is respond end. So that was very basic stuff. Let me see server number 3 here. So here what I want to show you is that, so not very fun, but what will happen here is basically I can run multiple servers at the same time and I'll never block my server. My server can always return the hello, and after 5 seconds, the world will be returned. So even if I run it with multiple servers, I do curl 5 or 20 times, I will still see hello on all of them. So I never block the request. So I'm like setting timeout, I'm using the event loop, and they showed you with the libuv aspect. So very performance. So I'm not going to show, we don't have time, but you can look it up on my slides and later on. I want to show you the concept of modules. How this module works. So I have here, I'll open this guy. Yeah, let me see if I can open another one here. Okay, so that's my module that I created myself. Okay, I have a separate file, I put it in modules, I can put it anywhere I want, and I want to expose a single method, and it's getUser method, okay? I'm exposing it to whoever will call the request, which is this guy, okay? So you see here, this line, that's how I'm requiring my module. And what I have in getUser is a function, okay? Why function? Because that's what I set the module to be. Basically, the .exports, inside the export, I can put whatever I want. So I can put a function, or I can put object with multiple functions. So let's say I want to do the save and the update and the delete all in this module. So then I need to do exports.foo equals function, and exports.blah equals function. Because in JavaScript, you can add whatever you want to an object. Just keys and values. That's an object in JavaScript. So that's how I'm using it. I'm just requiring it, and then I can just call it. So getUser, I'm calling it, and I'm passing a number 1, which is, let's say, the ID of the user. And the second argument is the callback. Okay? Why callback? Because here, in this line, number 11, I'm calling the callback. So I call it CB. That's the argument, right? And CB holding my function, my anonymous function, which I'm calling a number 11. And the convention is to always pass null if there's no issues. And if there's a problem, pass the first argument, the error. So the calling code will look for if ERR first. If there's an error, I can do something, log it, whatever, send me an email. And if everything is fine, I will display hello. And if I can show you from here, I can do node, and I can require it from here. Let's go to modules. And let's go to node. do X, require, models, user, I think, or users. Let's try user. Okay, so I have function, and if I try to call it, it will get an error because I had to call it with a function. So I need to pass here function. Okay, just want to show you the idea of how to use it. So I'm not going to actually execute it. So that's kind of CommonJS. Was it too fast or cool? So that's how you modularize your code, right? I can show you. Let's show you Socket.io real time. Let's show you Socket.io. So I have here, I think it's an HTML5 application, but it can be your Ruby site or whatever you want. And Socket.io. And let's try to run it and see. And node. Let's see. I cannot see anything. Let's try with the other browser. Safari. That's kind of crucial to show. It's a chat. Then we have to curl it. Okay. You guys have laptops? Do you want to connect to my chat room? Whoop. Is this it? That's my IP. You guys want to try to connect with port 3001? So I can say something, hello world, right? And I'm sending it to the server, to the Socket.io server, and in the Socket server, I'm broadcasting it to all the clients. 1018, 250, 228, 229, sorry. Nobody join me? Yeah. Okay. So this is the server. So all the server is doing requiring util. I'm using Express. Express is like the Rails in the node world, but it's actually like Sinatra in terms of the way it looks like, and they're not shy, and they're saying it. We're cloning Sinatra, and that's the dominant framework. But you don't have to use any framework. It's very simple to do without it, and I can show you on my GitHub. There's examples of how to build very robust website without it. But you can just configure your environment, and then you can do get. Whenever a request comes to my root, I want to execute this function, which will return index.html. Very simple. And this is the I/O, the Socket.io stuff. So I'm requiring Socket.io, and I'm calling the listen function. And as soon as the connection comes, I'm listening to data events that will be sent from the client. And then whenever any client sends me data event, I want to distribute the event to all of the listeners, the clients, the browsers. And I'll show you the code from the client. Public main.css, no. My script, okay? So this is the client-side code, which don't have to be, it can be a Ruby site or any other language. And I'm doing here, the important stuff is socket on message. Whenever a message was sent from the server, I want to add it to the text area that you saw. And here, this function say, whenever you click on the submit button, okay, I'm calling the say. And the say do socket.emit. And it sends it, and this is the data event. I can call it whatever I want to call it, as long as my server listens to the same one. I can call it John, as long as I have John as the first argument. So the server will get the request. In this case, it's just a text. I can set a JSON, and then you saw the server side. So that's basically it. See if there's anything else interesting here. Yeah, that's basically it for real time. There's also interesting real time elements in Node now. One of them called hook.io.
So the idea of hook.io is that right now you build a site or application, it's usually a big monolithic crap. So the idea of hook.io is to let you build small pieces of your server. So small little servers that are in the cloud, and hook.io will let you communicate between them. And the idea is that one of those servers in the hook.io is the leader, is the guy who you're sending all the events into, and he will distribute to the client. But what if the leader dies? So the guy who did it implemented a nice protocol, I can't remember the name, it's on Wikipedia somewhere, that lets, if the server dies, there's an agreement between the clients. It's a consensus-based kind of like protocol to choose a new leader. And this new leader will be the guy who, until there's one last man standing, that he's going to be the one who will be the client and the server. So it's very kind of like fault-tolerant system. So that's hook.io, and I think that you'll see a lot of applications that are designed, very small pieces that just connect to each other. And it's nice because each one can be in a different process. So if one fails down, another element of hook.io is if one process fails, it knows to restart it. So you don't need to care about the whole restart aspect. Oh, and I ran out of time. Very sad, but thank you.